Welcome to 1.8 multiplying rational decimals. In this video, we're going to review the concept of how to actually multiply decimals and how that relates to rational decimals such as negative and positive decimals. So first off, let's take a look back at our understanding of opposites like we looked at with 1.7 and multiplying integers. So in this first one, we have only one negative or one opposite, so therefore this whole product is going to be negative. We only have one opposite, so in this case there's no opposites to cancel and bring us back to the original state or location. In our next one, we have one opposite, two opposites. So the opposite of an opposite is a positive. It takes us back to our original location on the number line. And so again, just like with multiplying integers, having more than one opposite starts to make us look at where we are on the number line. So taking this problem in itself, let's take the first one and actually solve this one out. So negative 4 and 4/10 times 3 and 2/10, or 4/100 I should have said. Knowing that this is already one opposite, so we're going to have the opposite of the product, we can now look at this as simply 4 and 4/100 times 3 and 2/10. Because we're multiplying, we don't need to line up the decimals, even though it looks very similar to what I've done here. More or less what we're trying to say is we have 4 wholes and 4/100, extra. And we want to do that 3 times and then 2/10 of a time. So we could say, well, isn't that similar to 404 times 32? But we want to make sure the values are the same. So how did I get there? Well, to do that, I have to move the decimal twice to the right. So multiply it by 10, multiply it by 100. So that means in the end, I'm going to have to divide this answer by 100 because I already multiplied it by 100. This takes us back to solving equations, or a review of that as well. This one I have to multiply it by 10 to get to 32. So here I'm also going to have to divide my final product by 10. Now I could look at this as a whole as well, which is the same thing as saying divide my total by 1000. We'll come back to this in a little bit. So let's multiply. So I have here 3 times 4, 8, 3 times 0, 0, 3, and then 2 times 4 again, 8. Because this place value is done, I now want to make sure that I start in the place value that's being represented, and that is tens. So I don't have ones here. Everything that I'm multiplying with the 3 is saying I have 3 tens multiplying something. So I need to make sure I have a 0 for my ones. So 3 times 4 would be 12 tens, so I have 1 extra, so I put it up there. 3 times 0 would be 0 tens plus that extra 1, so put a 1. And then 3 times 4 again would be 12 for that. And this is just the typical algorithm. This is the typical way of multiplying whole numbers. So here 8 plus 0 is 8, 2 plus 0 is 2, 8 plus 1 is 9, then we have our 12. Now in this case we need to make sure that we put our value in its appropriate location. So I want to make sure that the decimal is in there representing exactly what this number value would be if I was dealing with the original problem of 4 and 4/100 and 3 and 2/10. So dividing this by 100 is no different than just moving the place value over 3 places, or the decimal, which should start always in a whole number to the right, 3 places. So 1, 2, 3. And if you notice the pattern here, that moving the decimal 3 places is no different than the number of zeros that we have. And the number of zeros that we have is based upon how many numbers are behind the decimal in the original number. So here we have, in this first part, we have 1, 2, 3. 1, 2, 3. And then here's our 3. And that tells us how many to move it back over into our final answer. So again, we already knew that this was going to be a negative answer because of the fact that this only has one opposite. So now we just place the value of the multiplication. So negative 12 and 928 thousandths. Bring your questions to class tomorrow as we'll be reviewing and applying this information.